Welcome everyone. This session will give you a quick overview of efforts in the space of automated deployment in Cerner. We understand the why. We spend more time doing deployments every iteration. We have skilled engineers supervising and performing them. We fix issues week after week and they never seem to end. We understand the what. This is essentially what we want from automated deployment. We want something which is reliable, requires zero involvement of personnel, completely repeatable, and a platform agnostic solution. Basically, something which we do not want to worry about. But how are we going to do this? Can we actually automate everything? Is zero intervention a myth? Well, let's get right to it. Let's dive in. Let's look at the two basic principles or our guiding philosophies in this venture. First, zero manual intervention. This is the primary goal. We would like everything to happen on its own, fix errors in case of issues, heal itself in case of downtime, and scale when required. Second, trigger points at each juncture. That can be defined to carry forward the deployment from the development team all through to the client in an error free and repeatable process. Let's get our hands dirty and see how automated deployments pan out. We see the developer working hard to meet the deadlines, and finally, the D Day comes to merge the code. The developer emphatically merges code into the source repository, and that could be GitHub or SVN or absolutely anything else. The source code management is independent of all automated deployment concepts. The developer steps out for a coffee, hoping all the deployment would be in place when he gets back. And this is where it gets really interesting. The source code manager gets into action, and a trigger is placed leading to the first step, which is building the source code. Remember, this should be configured prior and not manually triggered each and every time. The build process typically includes compiling or transpiling and running unit tests and also integration tests. The stability of the code is ensured with the successful completion of the build. The deployment process will be halted otherwise. This build can be Jenkins or its cousin Hudson, whomever you like. It is important that we have the most stable code in our master or main branch all the time to ensure a smooth automated deployment. At the end of the build process, we get our build outputs, which could be a variety of artifacts based on what you're building and what you're using to build. These could be packages or Docker images or any generic artifact. Again, the automated deployment process in itself is completely independent of the type of the build outputs. And there we go. We reach the second checkpoint, and the next automatic trigger is placed from the build process. Now that we have a stable artifact, the next logical step is to host them safely in a repository within Cerner. They could be Nexus repository for packages, a Cerner hosted Docker Hub for Docker images, or even the new kid on the block, JFrog Artifactory. Now we move to the essence of this process, the actual step of deploying the artifacts to an environment or a domain. In the cloud world, Cerner is currently exploring with using Mesos, an Apache project which abstracts CPU, memory, storage, and other compute resources away from the machines, physical or virtual, enabling fault tolerant and elastic distributed systems to be easily built and run effectively. Having such powerful resource management platforms are the bare minimum requirements for running a stable, flexible, and resilient automated deployment on production environments. To give you an example of how powerful resource management platforms can be, let's take a look at Marathon, which works in conjunction with Mesos in providing a robust production environment. Here we see two applications, Hello World Connected and Website. We can see the status and the resources they demand. But today we see the Hello World Connected application to be getting a lot of traffic. So why not scale with a couple of clicks? We change the number of instances supporting the application, and there we go. We see more instances of Hello World Connected running within a matter of seconds. Remember, this step can also be automated when there are spikes in the load. It's that simple, and isn't that cool? Now that we have deployed our application and the instances are healthy as we saw in Marathon, it's time to run the test suites as part of the validation phase. These are used to perform automated functional tests that ensure the stability and correctness of the application. So, what do we have now? An application which has been unit tested, integration tested, and is happily basking around in Mesos after surviving through the onslaught of the test suites. Now we are confident. We know our code is completely stable. Let's go live. And another trigger is generated. It's time to flip the proxy to redirect all the traffic flowing through the load balancer to the newly deployed instance of the application. The previous instance is destroyed and does not exist anymore and frees up resources it was consuming. As said before, this step is also automated. At this point, we are giving our clients a chance to play around with the latest and greatest features that were merged recently and not make them wait months. Finally, it's just simple math. Automated deployments equal happy clients, and nothing better than to see our clients happy and rejoicing. To sum it all up, this is what we have been through. All steps in one. These are the major steps that we cross to achieve the nirvana of automated deployment. That is, merge to source repository, configuring the build system, hosting and deploying the build artifacts, and flipping the load balancer while ensuring the stability of the application in each and every step using automated tests. Now that we are here, it's time to think even higher than this. So let's elevate ourselves. Let's take a peek into the world of orchestration. So far, what we have been talking was within one environment, one domain. Tomorrow, we will need systems that can manage all our environments in an automated manner and orchestrate all our build and deployment tools to reach a state where there's absolutely no manual intervention even across multiple environments. Spinnaker plays that to perfection. Spinnaker is an open source multi cloud continuous delivery platform for releasing software changes with high velocity and confidence. Let's take a brief look at the driving forces and guiding philosophies of automated deployment. An immutable infrastructure. This is a practice where software concepts or services are replaced rather than upgraded. Deployment strategies. These are powerful strategies associated with rolling out new versions of software and that reduce the risk associated with new code. Automation at every step promotes consistency and repeatability. This also covers the orchestration of complex processes. Operation integration. The process of delivering software must go hand in hand with all the operations of the software and vice versa. And finally, the biggest principle, which is the most common reason for having automated deployment. Small, frequent releases. Small releases reduce the risk associated with the delivery of new code. What we saw so far is the direction that Cerner is marching forward with different teams. Having an end to end automated deployment is the final goal, and many teams are well on the path to achieve this. We end here, and we'd be happy to take your questions.